the plan for this N and O. Plan would be, you will have about 30 lectures and 10 experiments as usual. Test 1 and 2, 15 to 30. Then lab, you should do some experiments. This will be 15. Homework plus project will be 15. So you have 60. Final 40. And this is the way we distribute. In 30 lectures, what are things I am going to cover? Later I will give you all the details. Yes. You have all the details. You have harmonic generation. Harmonic generation is the most important. Raman lasers. Raman lasers. Yes. Non-linear absorption and 2 plus 2 photon fluorescence. Fluorescence, solitons, optical bistability, and then applications. Where do you use all these applications? Out of this, I would take about 10 hours on this, another 10 hours on this. All this put together 10 hours. The reason being, this is how they are used in laser technology. And giving this kind of proportion to the teaching and your requirement to know, because this is the kind of distribution of their importance. When you go to any laboratory, I would see only 1 or 2 people do anything about solitons, or practically they have not come to the application at all. On the other hand, harmonic generated Raman lasers are very common, very important. You can place order. I say this is the Raman laser I want. You can get. These are all still in the beginning stages of applications, in the stages of development. Okay, with this, let us go into the details of our lecture. In the last lecture, I left this point. How light is produced. The picture I gave is like this one. This represents the center of nucleus of positive charge. This represents the center of negative charge. So center of positive charge and center of negative charge, normally they don't really coincide. There will be a small difference. This is called center of positive charge, center of negative charge. This is called the dipole moment. Dipole moment is, you can say this is E plus, this is E minus. So you can say E plus and delta, this one, the internuclear distance. This is called the dipole moment. This is how it is defined. This is the condition. No, 1 minute, one step before. One step. Now look at it. The atom is free. There is nothing disturbing it. Under this condition, center of positive charge will coincide with the center of negative charge. Positive and negative will be sitting on it. That is what you mean by neutral.
Neutral.
Understand? This is step 1. Second, I take the same atom. This is positive. This will be slightly distorted like this. Look at it. Then this will be negative. This means I have negative and there is a positive electrode. I apply electrode. Then center of positive and center of negative will be displaced, it will be slightly pulled. And this is what is defined as a dipole moment. This is mu is defined as E R. Where this is R. The E will not be a full E. It will not be 1 electron, 0.5, 0.3. It's just a displacement. Next step. This is for only one atom. Suppose there are millions of atoms. P is the vector sum of n mu. Why we say vector sum? You don't expect all the atoms to be in this like this one. There are so many of them. Some atoms will be oriented like this. Some will be oriented like this. Some may be oriented like this. So you must find out the vector sum all the dipole moment. That is called a polarization. That is how you define a polarization. This polarization, next step. This polarization now becomes a vector. This polarization is chi e. This chi is called electrical susceptibility. Susceptibility. This is the function of atoms or a molecule. This is a electrical susceptibility is a material property. Material characteristic property of atom or molecule. Atom or molecule. Now why I give this so much specific information is I can take hydrogen gas, put it in a box, apply positive and negative, then you will see the hydrogen gas, atomic gas, will have this kind of polarization. Instead of hydrogen gas, I can do same thing for benzene vapor also. In a benzene vapor, you have a big molecule. That also will have same. But only difference between hydrogen atom and benzene molecule is this. This is a material property. And this E is the electric field I apply. Next step.
And this is constant for any material?
For a material, it is constant. It's a function of temperature, property, anything, but it's a material property. next step. Instead of DC, direct current, this is the DC, plus minus DC, I apply. Instead of DC, we apply AC, alternating. Then what would happen? Look at it. One instant this is plus minus. So the center of positive charges will be, center of negative charge will be like this. After some time, this is minus, this is positive. Then what would happen? See, look at it. It will be like this. It will be like this with the positive here. It will be something like a egg. You know egg? Same thing. It will go like this. This is the positive charge, this is the negative charge. Sorry, since this is negative, this is positive. 1 minute. It will be like this. Yes, this is correct. This is positive, so wait. It will be like this.
Attractive.
Yeah, because it's positive. Okay. We have a positive, so the negative charge is here. Center of negative charge is here. When this is negative, this is positive, the center of negative charge will be here. So this will be oscillating. Now look at it. The cloud of negative charge is oscillating with the frequency of E. That means, look at this one. P is a function of time with E, function of time. So the frequency of oscillation of the cloud is same as the frequency of oscillation of the input wave. This is true. This is true only when E out is smaller than the E in of matter. This is something you should understand. Imagine this is a simple pendulum. Okay? If I don't do anything, simple pendulum will be like this. What is holding it to be in this? Gravitation. I just pull it, let it go. It swings from here to here. Why should it swing? It swings because again, I applied a force, pull it out. When I pulled it out, the gravitation was pulling it back. That is why it is going with this as a center of oscillation. So there are two forces. One is the external force,
And the
other is a gravitational force. if the external force is smaller than the gravitational force, the amplitude will be harmonic. When E out is much smaller than E in, the oscillation is harmonic. But when E out, look at this, is comparable, when it's not equal, or comparable to E in, the oscillation becomes unharmonic, anharmonic, anharmonic. An example for this is this. A very good example. I have a picture. Later you can see this one also. I have simplified this one. It will be a picture like this. This is P, polarization, function of time. This is time. Let me say the polarization is like this. This is the impressed frequency. This is the oscillating external frequency. Because of this one, what you will see? What will you see? You will see go like this. In fact, 1 minute. It will not be so big, so I must make it smaller. I can say, wait a minute, I will give still a better. Let me say, go like this. Then you will see the picture. I change this, whereas this will change a little like this. Understand? I give too much force, still the charge cloud within the atom changes but little. The most important is this is Vt, this is external frequency omega t. The frequency, since charge is vibrating, you will get light of same frequency as the incident light. That's all. The charge vibrates with omega, which is equal to omega equal to omega of out. So the scattered, this is very important, scattered, reflected, scattered or reflected light has same frequency as omega out. This is called linear optics. This is the region of linear optics because it is linear. On the other hand, laser interacts with atoms and molecules, the electric field, the E out, that means that comes from outside, is comparable to the E in. So, charge cloud undergoes distortion. What do we mean by distortion? Look at it. This is positive charge. Let us say this is the negative charge. If it is vibrating like this, it is harmonic. On the other hand, look at it. This is the positive charge. From here it goes here. Suppose it goes like this. This is a small ellipse. This is a full dot ellipse. It goes distorted. This is called anharmonic. How do you say that E out is comparable to E in? This is where you should go into laser. Let us calculate E out, that is the electrical field produced by the laser at the point of focus. By a laser, E out by a Q switch YAG laser. You must have done this one earlier. Let us repeat this one. This is very important. Take the example of our laser here. This particular laser has 1064 and this has 2 milliradian, 5 nanosecond. Energy per pulse is 100 millijoule. I am giving a realistic example and later you will do this one in the laboratory. 1064 nanometer, 2 milliradian, 5 nanosecond. $10 million. Okay. When this is focused, so this is the laser, the beam is coming here. I am putting a lens and focus. I put the lens of 5 centimeter. What is the field at this point? Field at focus. To do the calculation, we must follow this one.
Find the radiance, then find
No, first step, you must find out the peak power. Peak power is energy. You put energy by pulse width. Am I right?
Yes, yes.
This is what width? Pulse width. So this is 5 nanosecond. This will be 100 millijoule. This is into 10 power minus 3 over 5 into 10 power minus 9. So this becomes 20, 20 into 10 power minus plus 6 watt. That's a peak power. Okay. To calculate electric field, we not only need the power, you should know what is irradiance.
The radian.
What is irradiance? Irradiance is defined as the peak power, not the polarization, remember, peak power over
area.
area. What is the area? We must know what is the focal radius.
We find the radius.
The radius of the focal spot will be f theta, am I right?
Yes.
We have done all this, f theta. So this will be 5 centimeter, 5 centimeter, which will be 10 power minus 2, 5 centimeter, sorry, where is this? That's right, focal length is 5 into 10 power minus 2, theta is 1 milliradian or 2 milliradian, 2 into 10 power minus 3. So if I multiply this one, this will be 10 into 10 power minus 2. And then
Minus 5.
you have minus 3, all put together 10 power minus 5 meters, the radius of the spot. Area would be pi r square. Pi, you take it as 0.75. R is 10 power minus 5 meters square. Okay? So this will be 0.75 into 10 power minus 10 meters square.
So that's problem. There is a 10 cross multiply 10 power minus 5.
What is that? What is that?
Not Victor, not visit.
Okay. 10 power minus 5, so it becomes 10 power minus 4.
Yes.
Am I right?
Yes.
Right. You are right. Okay. Now forget this point. You make it as 1.
1, okay.
You make it 1 into 10 power minus 8. Just 1 minute.
Okay. Yes. لا حول ولا قوة.
10 power minus 8 meters square, right? Okay, then. So the irradiance would be, we can go here, irradiance would be power per area. This is 20 into 10 power 6 over 10 power 8. So this becomes 20 is 10 power 14 watt per meter square. Then eccentricity, note down this rule, this is given as irradiance, is defined as 2 epsilon by mu, epsilon by mu e square. So e square will be 2i divided by root of epsilon mu. This is, in fact, this is assume that you do all experiment in vacuum. Then this is defined as 1/377. You know that? This is defined as 1/377. You have heard about this?
No.
The speed of light.
Huh?
The speed of light.
What is it?
This is?
The speed of light.
This is right 3.
You have if you have any data book, you will know. Just remember this one. You go to any data book. This will give you dialect. This will give you the dialect, or this is called the free space dielectric constant. This is called permittivity. This is called permeability. These are, one is electrical constant, other is a magnetic constant. It's a standard value. If you do for free space or for air, this is a number, 1/330. This is a standard number. So this becomes 2i377. Now, look at this. E square will be 2. What is the irradiance? Look at this one. 20 into 10 power 14, right?
Yeah, right.
Times 377. Calculate. You have a calculator? No, you have your mobile. It's okay. I can do the calculation. Don't worry. What is
I
important?
have one.
Don't worry.
Calculator.
We don't need it. For me, for simplicity, I will make it 400.
400.
That's all. See, this will become 40. This will be 400. This becomes 10 power 14. So look at this one. This will be 16, 1, 2, 3. Okay? Into 10 power 14. Now, the simple way I do, I will make this 160 into 10 power 16. Then, this is E square. So, E will be 160. What is the square root of 160? I would say. It will be about 14. No. Let's say 12 approximately. If you take the square root of 160, it will be about 12. 12 into 10 power 8. Or this will be 1.2 into 10 power, this is important, 9 volt per meter square. Electric field is 1.2 10 power 9 volt per meter square. This is a very high electric field. This is, in fact, it is greater than the electric field available within the atom. Again, go back to the same example. I do the simple pendulum. I just give a push. So the simple pendulum is going like this one. The simple pendulum is making a periodic simple harmonic oscillation because the force given by me is smaller than the gravitation force. If I push it, The simple pendulum will go like this. Understand?
Yes.
When it goes like this, it is not harmonic. Same thing here. It becomes unharmonic. Okay. The conclusion is the best way. This you take it as out. Understand?
Yes.
This is the electric field applied by outside due to laser focusing. I leave it as homework. Calculate the electric field inside a hydrogen atom. I leave it as a homework for you. How will you find out? You can do it very easily. Look at this one. This is the nucleus of a proton or a hydrogen atom. Here is the charge of electron. The electric field of this on this electric field is always E. Look at it. E. This is the force, not electric field. It will be E square. The electrostatic force between this and this will be E square over 4 pi r square. Am I right? That's electrostatic force
Yes.
K.
between charge. Put
Yes.
all the K here.
Yes. Yes.
Yeah, K.
Okay.
K, Q1,
You
Q2
put
over.
anything there. It's look. You can say.
Yes, we know that.
Okay. The force is K E R square.
Yes.
Right.
Yes.
Now look at it. The field
It's just one E,
is
just one.
K E R square.
Yes,
You know the charge of electron.
electron.
You know the distance between these two.
Yes.
You know K, calculate as homework, compare the electric field. This electric field which is existing within the atom is comparable to electric field here. This is where nonlinear optics come into the picture at all. Okay. Now, when E out is bigger than or equal or comparable, you can say comparable to E out, E in, P equals chi, which is a function of intensity, epsilon. You see the point? Before that, it is not dependent on the intensity, it is a constant. Now, it depends on the intensity. Once this comes, I can put it as E as chi naught. The intensity again influences the electric field, so chi naught plus chi 1 E plus chi 2 E2 E square, like this. I put chi 0 E, chi 1 E square. So, P,
Dr. Chi 0 is
chi 0,
the value.
it's a constant value independent of E.
Mm.
No,
For the material.
material.
Mm.
This is the one which changes due to electric field. If this is small, you can make it 0.
Correct.
Okay. So P now becomes, look at this one, chi naught plus chi 1 E plus chi 2 E square times E. So now it becomes chi naught E plus chi 1 E square plus chi 2 E cube. This is true whether E is direct field or alternating field. When light from laser falls on a material, the charge cloud of the material undergoes non-linear oscillation. Why non-linear oscillation? The laser light is oscillating, alternating current, alternating frequency, non-linear oscillation. Assume, put the electric field of laser is E naught sin omega t or cos omega t, cos of E naught cos omega t. We assume it is E naught cos omega t. Then just a substitute, P would be chi naught E naught cos omega t. And here immediately must put pt because the function of time, because it is changing with time. E naught cos omega t plus chi 1 E naught square cos square omega t plus chi 2 E naught cube cos cube omega t plus something something something. But we can say but chi 1 is smaller than chi 0 and chi 2 is smaller than chi 1. Chi 3 would be smaller than chi 2 because all the non-linear terms will be becoming smaller and smaller. Under this condition, other things you make it equal to 0. It's not really 0, equal to 0. Then coming back to this. So we consider only 3 terms. So Pt is chi naught cos omega t plus chi 1. This I can put it as E square. Cos square I can take it as 1 minus cos 2 omega t over 2. Am I right? Cos square t is 1 plus cos 2 omega t. Yes. Am I right? Cos square omega t is 1 plus cos 2 omega t. 1 plus cos 2 omega t over 2. Okay? Plus chi 2 E naught cube. Then you have cos cube omega t is cos, 3 omega t plus. These trigonometric equations I never remembered even in the school days. It's always a problem for me. Cos 3 omega t plus 3 cos omega t plus 3 cos omega t over 4. One minute, is it plus or minus? I don't remember that one. I checked subsequently. You have any calculator?
Calculator.
In the calculator you can see if it's a plus or minus. I don't remember.
Not know is it this or not.
Huh?
This, you need this one.
No. You find a equation for cos 3 omega t. Yes, this is yeah, plus. I got it. Plus.
Look at that.
Plus. Okay. Cos 3 omega t plus cos 3 omega t plus 3 cos omega t over 4. Understand? Now, immediately, now we will simplify this. This means equal to, look at the expand, cos chi naught e cos omega t plus, look at it, you have chi naught e square 1 over 2, so I can put it a half chi 1 e naught square by 2, right? Okay? Half chi 1 e naught square, this one, plus. I have another term which is 2 omega 2. So this will be chi 1 e naught square over 2 cos 2 omega 2 plus. Now look here. I have one more term with the cos omega t. So what I can do, add here. This will be chi 2 e naught cube, okay? Cos, you put 3 here. 3 chi 2 e naught cube, okay?
Over 4.
Over 4
Cosine.
cos
Omega t.
omega t. Then plus I have here chi 2 e naught cube over 4 cos 3 omega t. So look at it. 1, 2, 3, 4. 5 terms. Now I add all this together. So what? First thing, this one. First I will have chi 1 e naught square plus chi 0 e naught plus 3 pi by 4 chi 2 e naught cube put together, take cos omega t plus half chi 1 by 2 e naught square cos 2 omega t plus chi 3 over 3, sorry, 4 A naught q cos 3 omega t. Now put all this. Now this represents a term which is not dependent on frequency. This is called the direct current. And here is a term, a polarization which has the same frequency as the incident frequency.
Linear.
So this is called linear harmonic oscillator. Linear. And here is the one. This is the funniest thing. This is the new frequency, which is 2 times the frequency of the incident wave. This is called second harmonic generation. This is called third harmonic generation. That means now, when you shine a laser on some suitable material, you will have 3 alternating polarization wave producing, when we say polarization wave, it is meaning the charge cloud is vibrating. When it vibrates, it will produce another light. It may be less. It may not be in the same direction. Whatever it is a light of same frequency. Now, you have 3 frequencies, same frequency, second harmonic and third harmonic. Plus there is one DC term which is not dependent on frequency. Next important point is, look at this one. Chi 1 is much less than chi 2. Sorry. I will say chi 1. Chi 0 is bigger than chi 1 is bigger than chi 2. Okay. So this will be stronger than this. Understand?
Yes.
This is stronger than this. This is stronger than this. But it is there.
Stronger in intensity.
Intensity. Because this represents the amplitude of the wave. Correspondingly, the square of it gives the intensity. That's all. So, we have 3 waves now. This is called the fundamental. Fundamental, intensity of fundamental is greater than intensity of second harmonic, greater than the intensity of third harmonic. This can be pictured in the following fashion. Polarization now becomes like this is called non-linear. For comparison, keep this one. What is linear? This is linear. You know, linear means, perhaps you should know. See, I buy 10 shirts. One shirt, 10. One shirt is 100 riyal. 5 shirts will be 500 riyal.
5.
Am I right? This is linear.
This is linear.
What is non-linear?
Price change.
Like 2, 4.
No, I buy 1 shot, 100 riyal. If we say 5, I will give you 400 riyal. You see, there is a discount.
Yes.
This is called non-linear.
You get it?
Okay? This is non-linear. This is non-linear, not in this fashion. In this case, the input is less, output is more. In a discount, it is less. In any way, both are non-linear. Understand? Okay. When this is like this, then what I do, I put it as a Pt. This is time. Here also I put is Pt time. Then, since I put my light, look at it. I put a light on this. This is the incident frequency. The incident frequency is not non-linear, remember. This is T. But this will lead to, look at this one. This will lead to more here, look at this one, more here and less here. Understand? The polarization is more on one side, less on the other side. Because, look at this one. Okay?
It means in one direction, in X direction or Y direction.
In any one direction, imagine, I send the laser beam like this. Okay? I have a material. If the laser beam is very strong, this material goes more here and less here. You understand? It goes crazy in one direction because it is forcing it to behave unharmonically. I can give this example. Take this example. Look at it. This is harmonic vibration. This side and this side is same. Suppose I go and come like this. Look at this one. You see that? This side I go more. This side is less. A vibration, a periodic vibration like this can be Fourier analyzed into 3 frequencies, many more frequencies. It can be put like this. It will be one. Write down carefully, you will understand the whole idea. What I mean is, in this time, this makes one wave, understand?
Yes.
This makes one wave. In the same time, it makes 2 waves. 1, 2. It is like, I go for a walk. Look, my son is coming with me. By the time I make 1 full step, my son makes 2 steps. Understand? He is moving, frequency is high.